So thanks for having us. As Kendra said, with Jan and others, we're here to work on the Robotics conference. We'll be here later in September, and I'm sure we will see all of you on this many. And I mean, we were asked initially to have a talk, me today, Kendra on Wednesday. Many of you go to Rome, I think. So we obviously not going to have 2-hour lectures or 1-hour lecture after the other. But it was also amazing to know that Norman Huck's PhD defense was this morning. So things you, of course, should never do, quickly change your slides before you give a presentation. But I thought, just also in light of what was discussed this morning, which was a really remarkable PhD in itself, I have done that. So as Okun said, at UTS, the University of Technology Sydney, within the Faculty of Art Design and Built Environment. It is the youngest university within Australia, and it's only 30 years old, so that comes with its pros and its cons, and some really interesting things for us, because it is a university of technology for us as architects, and our group, the Transformative Technologies Group, gives some really interesting opportunities around that. As many of you know, and you hopefully are all familiar with the work of Bill Mitchell, who was Australian, is that architects tend to draw what they can build and build what they can draw. And I think it's in most of the work that also happens here around the world, I think it's very important to keep this in mind, that architecture is also as much bound to its varying means of representation as is also linked to its material possibilities. There's a very wonderful book for most of you, or some of you might speak German. Christian Gens here did a really fantastic PhD. And this is actually some excerpts out of his book, and it's called Tools for Ideas, Werkzeuge der Ideen. And it's very important for our work that you must be aware that our modes of thinking, our modes of expressions, the tools, techniques, and media, and our perception, of course, interlinked with each other. Therefore, how we make models, and we're very interested in the kind of the progression of notions of the model, how we draw things, the kind of precision and imprecision, and I think what also Kendra was saying about new technology and the kind of imprecise nature maybe of some of this technology. Also the ability to kind of modify existing tools, which many of you are doing, and the kind of tools and I guess conventions that we have within our profession. Yeah. So I'm not sure how many of you have used this. I unfortunately am not very good in it. The French curve, but we of course always invent and innovate our tools of representation. This of course in a very analog way, but you draw the most beautiful curve with this. And the relationship between our modes of representation and what we're able to build, so the discussion that happened today also about if there is maybe a new, what does mesh mold possibly mean in terms of a style, and of course there's different ways to discuss style, because style can be based on the material used, based on technology used, and based on an era of use. So maybe this can become a little bit interactive as we go. And the other interesting thing I thought was the role of geometry. And within the universities in Australia, so I was first at RMIT, then at Monash University, and now at UTS, I noticed that we don't really teach geometry any much more to students. So while I always think, that's the kind of broccoli that you need to have, like it's a kind of key knowledge that if you are not aware of geometric constraints of what different geometry does, you are really within a constrained set of ideas. It is something that I just want to bring this up, that I think it is really, we need to come back to more geometry teaching in a principled way, because, again, a slide I had in there, the freeing of our formal language through this, but also the restrictions of tools in terms of what they leave out. As you all know, the Nolly map did not talk about scale or the height of buildings. It was just purely a two-dimensional representation. So within our group, we certainly don't use the computer as an oracle, and we don't just use it as a pure drawing tool either. As you might know, Ludwig Wittgenstein, we really love this quote within our group, the limits of my language are the limits of my world. So the kind of language that you use, the way you express yourself is very important. Simultaneously though, it is very important to understand that software sets standards, and we had a bit of a discussion about what maybe non-standard is, and Mark Barry was my PhD supervisor, and he once said that, standards change, and what of course is assumed or regarded as a non-standard now will become a standard later. And that's, I think, a quite interesting discussion that came out of this defense this morning as well. Simultaneously, because we're creative people, it's important to understand not only that software increasingly determines what can be designed, constructed, or even how design occurs, and certainly the kind of design teams, the kind of interdisciplinary teams that happen, but also that encodes a series of assumptions. And I mean, just if we all use the same tools, and then back to the question of style, is how far do we actually really break into new language? So yeah, we truly believe that you should make your own tools. I mean, Kendra just showed you in the most beautiful way how creating your own tools enables you to do new things. And we also do this, we look at how other disciplines work. So this is a small video. Oops, that was the wrong video. But for us, it is using the knowledge of other disciplines in order to expand and maybe transform what we assume is our own disciplinary knowledge. To give a bit of background, when I was a student, I worked for Tom Kovac. In Australia, I worked on the non-standard architecture exhibition that was at the Centre Pompidou. I was responsible for making those, two models. Here's Jono, I think, where is he? Knows Jono from Vito Acconci in Paris, putting this big model together. But at the time, what was interesting is that was the kind of the digital design and a completely distinction or a complete divide from the materialization of these things. So this was popular, when laser cutting was hip and 3D printing was just, starting, was still quite expensive. And what was interesting for us that, we did this, and of course, Tom was asked to to produce this very large model, that when we built it, it always fell over. So we quickly needed to design this little foot in there, which hopefully stood or was, still within Tom's overall, iconic design for the Twin Towers. But at the time, as a student, it was like, okay, there's a really huge divide. So how can we bridge this? We did things for the Venice Biennale. And then later, I worked for an architectural practice called Minifee Nixon, now Minifee and Sky, where we explored the idea of computational design, of course, using patterns that you're all familiar with that we can replicate through algorithms, but looking at how we can actually build some new or complex facades with very, very simple existing techniques. So of course, the facade was built. You can see there's actually a repetitive mold or repetitive pattern, even though it looks non-standard. So in kind of this discussion that we also started to have this morning about efficiencies within the fabrication of things. And of course, working very, very closely with the fabricators who know how to make this. Yeah, so this is us nicely dressed up, coating a piece of model in the courtyard. As Orkun said, together with Paul Nicholas, I have a small, completely dormant architectural practice, I have to say, since we're both full-time in academia, called Mesne Design Studio. This is one of our first projects, where we, actually our only build project, I have to say, where we engage with a fabricator. We were asked to produce a screen for a very famous racehorse that only really interests people within Australia, because that horse is very, very famous, working within CATIA. And what had happened is that, of course, it's very easy. We didn't need to produce drawings for the museum for their internal control, but there was no requirement for a drawing of the making process. But what had happened is that the fabricator, while they put the model, they needed to mill it both sides, had flipped it the wrong way. So for us, it was an interesting moment where, of course, while this is all very, very easy, how do you keep control over these things as well? This is it's called FarLab. If you ever want to know something about Australian horse racing, Google FarLab, and you'd be amazed how a nation stops around that. With our practice, we successfully lost many competitions with others. We look at other disciplines, and we look at how maybe new ways to encode lots of pixel information within, or how algorithms are developed to do that. and what the kind of, in this particular case, the door-technical aperiodic tiling gives us maybe new compositional strategies for, in this case, the Melbourne School of Design at Melbourne University, that Nada Tarani won. Or in this project, looking at intensive patterns, that again, we successfully lost. But sometimes we also pick something up and win something here together with Ian Maxwell, who is a colleague of mine at UTS and in Huang, where we looked at, or basically developed an interactive table where we're interested in the kind of history of lace making, the history. This is Ada Lovelace, the woman who translated Babbage's differential engine, and speculated in there what computation might do. There's another Lovelace, but as a recording, I might not refer too much to her, but you can look this up. But for us, it was an interesting moment where the exhibition or the competition was called Lovelace, and it was about the innovation in what lace means. So instead of depicting lace as something, just a leaf pattern out of nature, for us, we thought, okay, what do we now understand about the world more through computation? And developed a series of tools where people in the exhibition could interact with those different tables, submit them, and there would be a laser cutter that would later cut us out. So we were quite experimental, from very small scale to large scale. Of course, also with our students in teaching, so I'm both, in my academic role, of course, I have to teach as well. We work with students with physical models, with digital models, are quite experimental with this. Look, for example, here, when I was at Monash University, I had the great opportunity to work with Professor Gary Egan from the Monash Biomedical Imaging Center, where they have, well, here it's the CERN, which is, I'm not sure if it goes clockwise or anti-clockwise. There's the synchrotron, which is basically a large particle accelerator, so how other disciplines actually look at engaging with the material, do a section based on intensities rather than on the orthographic drawing that we're all used to, and also the other tools that they use, and for us to be able to speculate what that means in terms of a new formal language. And of course, all the prints that the students did were then pinned up as if there would be an X-ray. So the lab itself is, or the group is a space for experimental making, where we work with people from material science, here a collaboration at Monash University, with Yugi Estrin, who has a patent on the osteomorphic block. I think Philippe's group are quite familiar with something about self-interlocking bricks. That was developed on a very small scale, micro scale. It was actually for bulletproof vests. When materials don't want to mix based on the chemical setup, they're combined, or they make a compound based on the geometry. So we have this opportunity within our research group to work with these people in order to speculate what happens, and of course also then to build this as a prototype. That's something that's very at the heart of ours, to test things at building scale, as you guys hear as well, but also to put students outside of the comfort zone of the university. So in the background you can see the walls that I had the opportunity to work together with Philippe many, many years ago, which was in the ground floor space of Grimshaw Architects. So students working off campus on a project with something, but also the great opportunity that we had James Bellamy over, who worked together with Philippe remotely. They actually never met, I think, before, and Rice on their project. So it's quite important, I think, to always have people who have an intrinsic knowledge of materials and process there, and not to assume that as an architect we know everything best. And in terms of back to the discussion from this morning, is that the education that we have is certainly as we're facilitators and we're coordinators of people, materials, and things. And I truly believe that architecture materializes our social and spatial connections. So as I said, the group itself believed that to act materially is to act on the world, and this is a bit of an overview of what we do within our group. We're not just architects, there are people from product design, there are people from interaction design. Within the university, we also have people who work in computer science. Of course, for example, one of my colleagues, Dave Pygram, who was here with Supernova. So they were part of this group that worked with Philippe on this project. That is an opportunity to always test things at large building scale and how these things are also tested in the real world. We work from the physical and sometimes in a real MacGyver style way to always test these things. Here again with Paul Nicholas, a collaboration at Grimshaw Architects about bending active structures that later then became a proposal or a project for a music festival that won an award. And you know, what a great idea, or what a great reward actually for the students to go to this electronic music festival and have free tickets for an entire night. Our setup is slightly different to yours. This is our robot lab, a lot more modest. But we certainly try to punch over our weight. We develop our own computational tools, like this one here, in order, of course, as you know, encrypt all the material information that's available, or to not just have a complete geometric representation of a model, but also a model that has fabrication constraints and all the fabrication information in there. At the same time, we're very interested in the kind of cyber-physical and the kind of relation between the material and the machine. In terms of simulation, our interest is that how can we actually innovate? Oops, sorry, this should play. Maybe not. Oh, bummer. What you were supposed to see is this most amazing video that would completely outsmart Kendra's. But how, in a traditional simulation way, a simulation, you would first have to predefine the geometry and hardly can add new geometric elements to that. So in this particular collaboration with Paul Nicholas from CETA was to attempt how can we actually have a simulation run where we don't specify the material, but we only let the simulation first specify what will be the ideal geometric layout, and then based on the material information that we have, inform the simulation in the next step, for example, with different diameters of rods. We work on projects on augmented reality as well. We're not so interested in virtual reality ourselves, and we really want things to come on the building side. While iPads and all these technologies, of course, already used, they're also a very huge occupational health and safety hazard. Dripping hazards on construction sites, as you know, they're very messy. So our interest is how we can maybe do this with a virtual overlay. As you know, set out is a very, very big challenge. So once you get your set out wrong, you cannot really expect to get everything else really right unless you have some really incredible details. At the same time, also the as-built, which is something very interesting. So rather than having your good old either little 3D scanner in the room or somebody doing a markup on a drawing and saying, this is what it is, the kind of opportunities to, in real time, do an as-built, synchronizes, for example, with a building information model and coordinate discrepancies on site. So this is some of the research that we currently do. We have the opportunity to work with people, the Center for Autonomous Systems, which is our robotics people over there. And we have a School of Software, so Nico Pietroni is currently collaborating with us on meshing strategies and tessellation patterns for a number of projects. I might skip this. At the same time, of course, with people from civil engineering, how we can embed or analyze forces within a piece of geometry and then inform the tiling of that. At the same time, though, we also, and I don't have maybe as much sound as Kendra did, work with artists. So this is a video by Melbourne-based dance group Chunky Move. What you see there is a dancer that has just been given a set of instructions. All the projection mapping happens in real time. It's not predefined. It works based on sensors. Frieda Weiss, who is a German engineer for the arts, he calls himself, did all the programming for this. And for us, it's interesting because we're interested in, of course, sensor feedback, also with some of the robotic work I'm about to show you, is how other disciplines are already quite far advanced in terms of what real-time feedback actually means, and how they just work very intuitively with these as well in the design space. So that work is relevant because concepts such as artificial intelligence, machine learning, sensors are things that I already worked or used here in this in a quite sophisticated way. And we always find it as a kind of interesting point of reference, and in collaborations, how we then can inform, of course, our own work with this. We also develop new materials, so we really work from the micro with people in material science, or people from physics. So we're part of a center for, it's similar to an NCCR, it's called the Center for Excellence within the Australian research context. So I am an affiliated investigator on this, where new energy materials are developed by chemists, by physicists, and how, of course, we can translate these into our built environment. From the meso level, and of course, with Supernova's work, something that we really would like to do within Australia, but certainly it's a different funding scheme. So some of the work, I'll just show you a few projects quickly. Our themes are around bespoke prefabrication. I think there's a lot of resonance with the research here, around sustainable construction, and of course bespoke materials and processes, as well as some sensing ecology is a project Ian Maxwell is currently working on. While I was at Monash, I had the opportunity to work with students on this project. So it's a sound shell that was funded by the university. It has 12,000 geometrically unique components, of course, something you only do when you have a whole army of excellent students, because otherwise the budget of such a project would certainly not be enough to do so. And it was in collaboration also with Kassel University, was a guest professor at the time, with Markus Schein and Sascha Bodenberger from Bollinger and Krohmann. What's interesting about the project, while it needed to go through complete planning as part of the redevelopment of the campus of Monash University, we had this challenge that the builder, for example, was completely new to such a process. So the labor force within Australian construction is very, very uneducated, one needs to say, because many of those laborers are actually just backpackers who never worked on the construction side. Of course, they are very fantastic people in the construction sector, but the majority are actually just backpackers who, like me, when I came to 96 Australia, just try to earn a bit of extra cash, so they have never been on the construction side, and therefore, how do you actually communicate information to these people? So we built a one-to-one prototype in Kassel that worked really, really well, but when we came onto site in Australia, unfortunately it didn't happen because the labor force that we had was not quite up to scratch. But having said that, the students worked very closely with the fabricators, so they were in the yards. We couldn't at the time fabricate all this within university, so they learned from the fabricators, but they also educated them. For example, these CNC bent galvanized steel cleats for structure. At the time, we just had our first robot in university, so needed to learn all of this and try to innovate because the prefabrication time was so short in the end. We needed to make molds, and we needed to make them out of foam, marking them up. The students were on site installing the whole thing with backpackers, trying to keep control over this. This is a view of all the timber cladding, the kind of complexity around that, which you, of course, could guess if that's really necessary, but we thought we'd try this. But also a student and the fabricator getting confidence in the information that we had, and a student running there, very large CNC machine, and that was their kind of key bread and butter machine. So there's a lot of trust building with industry partners around this. And within the Australian context, one needs to say that we just don't have the kind of Mittelstand that exists within, the Swiss or German context. So it puts things sometimes a bit more challenging, but also we see it as opportunities. And just some impressions of this. As you can see, there are some, there's water damage on this, unfortunately, because we had issues with the contractor. But it was something where students designed the entire thing on site, and then, of course, there was a big party in the opening. The other project is a collaboration with Paul Nicholas from CETA. He was recently out in Australia where we worked on this. You might be familiar with Paul's work around incremental forming that he did at CETA. This particular project was so looking at a different material system, in this case copper, and also looking at a standard connection type. And I just thought this morning also with Norman said, I mean, looking at this amazing roof, his work, other work, it seems that the connection is the thing, actually, that everything else is, of course, non-standard, but the kind of non-standard placement of standard connections is where a lot of the work that I think we do everywhere seems to be at. So anyway, we can have a discussion about this later. If you're not familiar with incremental forming, this is the tool you need. It's different to stamping. You basically drive the material. You change on a microscopic scale the material. You harden it by deforming it out of plane. And once you understand the forming limits of that process, you can really drive the material very, very far. Where traditional stamping would already tear the material. So this was with a group of students from first-year architecture students to a couple of my PhD students from the group, where they did extensive material testing and then built this one-to-one prototype. You know, a first-year architecture student learning how to have a completely integrated workflow from a digital to a physical model was kind of a big achievement, but also when they then started to build it, we of course had digital representations to talk about the construction sequence of this as well. This is a robot lab from outside. If you ever are in Sydney, you find us if you walk from Central Station to the Powerhouse Science Museum. But as you can see, it's a very big public interface and also acts a bit as a gallery to us. Here are a few shots of the final form. So the process or the project tried to test, as you are very familiar, it's less a problem at the moment in Australia around thermal insulation. It's more about cooling. But within the European and Canadian or North American context is that the regulations change and there's always another added few millimeters every year based on regulation to insulate your building more. Therefore, the facade gets thicker. Therefore, the substructure gets beefier. And your entire facade gets heavier. So how can we actually think about this process to develop lightweight facades so we can have a lighter substructure as well? And of course, we're interested in non-standard architectural panels or how we can maybe eliminate the expensive mold-making process for these things that would be required in stamping as well. I'll skip that video because I think you can imagine what it is. Another interesting context that is possibly shared between our two countries is timber. We have a really, really huge challenge at the moment in Australia is that we have basically 2 million cubic meters of timber. It's evenly divided into hardwood and softwood. The softwood was produced or planted for sawn timber boards. The hardwood, though, was planted mostly for pulp log. What pulp log is, you basically have a beautiful piece of timber, you make it small, either you export it to Japan and you import a much more expensive paper back in, what Australia has been doing. Not quite sure how the business plan worked there. Or you basically make other low-grade building products out of this. And this entire industry has actually gone belly up in Australia. So we currently have all this hardwood forest that is structurally deemed, or that timber is non-structural based on the building codes, and nobody knows what to do with it. So one of the projects we're currently doing with the University of Tasmania is how can we make building products, for example, a floor, using the hardwood timber, because the regulations need to always have 1 meter clearing between a knot, which is a very old standard, which is basically a person standing there going, nah, that doesn't work. This goes into the rubbish or gets used for something else. We work together with our people from the robotics group around vision systems so we can actually now measure where are these things, what is their real implication on the structural capacity of the timber, and in order, of course, to place very strategically low-grade timber within the compound of, for example, a large spanning floor. The other project is a PhD candidate of mine, Daniel Tisch, who is at the University of Michigan, where Kendra initially studied, together with Wes McGee and Jeffrey Toon, a PhD student, who looks at the possibilities of 3D printing or additive manufacturing and thermoelastic polymers, so elastic materials to print them. As you know, with additive manufacturing processes, the kind of material bond is a big challenge, not just only if you try to 3D print with concrete, but also with plastics. So this is one thing that Daniel is currently investigating, of course, with a kind of active engagement of geometry and how we can maybe use feedback from structural analysis in order to inform the kind of placement, various strategic placement of material, not just in terms of its thickness, but of course also in terms of location. So he's done some small proof of concept models using Seska's chair and developing bespoke processes around this. He's currently working on a larger structure around this. And together with our robotics people, we're looking at how we can have new or more advanced robotic sensing facilities on those robots in order to be able to react, not quite in real time as you saw before with some of Kendra's work or the artists, because the process, of course, is a lot slower, but how to give the robot actually autonomy over the process. And working very closely with them around occupancy maps and other things. Oops. I mean, you also robot print. The last two projects, quickly, are very small projects. We're working together with Nico Pietroni and Saddam Malek on lightweight 3D microstructures that we 3D print, as well as on a cable-suspended robot that Ian Maxwell has recently developed with our people in CAS, and hopefully this plays. Sorry, I just got the wheel of unfortune of Mac. And your connection is not private, warning, in my browser, so just give me a second. Can you see this? Oh no, I'm still. Wrong side? No? Yes. No, I can't see it. And I hope there's no cat movie playing in a second, thanks to YouTube. Here we go. So it was quite fascinating to hear from Kendra, of course, about intuitive robotic interfaces. Yeah, because of course a personal construction site will not be able to just interface with a system like that. Is there a cat movie now? We have to cut that out of the recording. And yeah, all the kind of bespoke required interfaces, tools, and control mechanisms. Yeah. So yeah, that's it. If you have any questions, you can email me. But I just wanted to quickly finish with those 3 quotes. Hopefully, we have a discussion. And this is really informed by some of the discussions or conversations happening. That the thought of every age is reflected in its technique, and I think we started to talk about maybe style. And of course, what Philip Glass said, a new language requires a new technique, and how you're very much involved in this. And I was wondering how mesh mold would draw that class. Because, yeah, if it's about style. Anyway, that's me. Thank you.